Hello and welcome guys to my not to my to our live stream. We are in day 15th of completing all the techniques of the sub-array. We'll begin soon in a couple of minutes until the rest of members join our group. Waiting for a couple of guys until we start again. Hello. So let me check who all joined. Hello guys, let me know who all joined guys quickly. Come on guys. We are waiting for 1 more minute from here and then we'll begin the session of today to sum up all the array techniques which we have learned till this point of time. Okay, so Achal and Harshit joined and I'm waiting. Okay, I think I don't know who else is there on the stream. Okay, we'll begin the revision of today's class. We are revising today so that we will be having an exam on the coming Sunday. Exam on Sunday. Mahima also joined. Exam on Sunday at 10:30 a.m. sharp. Those who are there in Pune will be at my house only, and those who are not there in Pune, we can join it through some kind of Zoom or Google Meet invite. Until then, we'll begin the story for the day, and that story goes like: we have 12, not 12 exactly. We have 13 techniques to revise. I'll take every technique a very quick look. We'll have one example or maybe more than one example to make sure that we are having that example or that technique in our brain. Stop me wherever you feel that you are not able to revamp or take that particular technique. I'll begin with this. I'll begin with this. Prefix sum, then we'll go with difference array technique. So these two techniques are basically meant for, so for prefix sum I'll say this is meant for online query. You know what online query is? So online query means online query. So I'll take the prefix sum first of all and then we can move forward. After this class, after today's class, we'll be starting grid. So we'll be having next class on Tuesday because this Saturday we are having off in so that we can prepare well for the upcoming exams. And post this, we'll be starting for 2D grid or matrices, whatever we can say. I'll start with prefix matrix first of all. Prefix sum. So prefix sum, you guys remember that we were given an array like 1, 3, 2, 5, minus 1 and 6. So the prefix array for the given array is 1, 4, 6, 11, 10 and 16. So this was the prefix array. Subsequently you can like moreover you can also calculate this in this direction, and we more often call it as suffix array, right? So this technique we use for online queries. You guys remember online queries question? Online queries like suppose if you have to calculate the sum of array indexes from 0 1 2 3 4 5. So if you have to calculate the sum of array indexes from 1 to 3 or like 1 to 2, so like usually you can just if it is having only one query, like queries, like I'll write queries over here. So the query says that if you have only one queries like 1 2 3, then you can have a simple for loop and you can calculate right from index 1 to 3. But if you have more than one expected queries, that's what we say online query question, where we are having more than one queries in our input, like an array will be given, and they will give an n number of queries. So like here we can go from 2 to 4, or we can go from 1 to 5, or we can go from 0 to 3, something like this. So this is called online query question. So if you are having some kind of online query, or you are given you are asked for some continuous sums, then usually we use this kind of techniques, right? So this technique only. So you might remember, I'll open our question so that we can I'll open our question so that we can quickly see that which question I will get a glimpse. So you like you might be remembering questions of like we did a question where we were given overs, that like suppose we are given some overs, this array is known as overs array, and like we are having 0 1 2 3 4 5 6. So initially there like ideally there is no 0 over, so I'll take it one based index array, and we are given like 1 2 5 0 6 12. So these were the number of runs. So usually you might have seen some kind of matrix coming in our like stream once we are watching cricket. So they will say from over 1 to 5 they put this much amount of run in this like in this power play 1. They like if we say this is a power play 1, so they will say this much amount of run they have put on the scoreboard. Then from over 2 to 4 to 6 they will say this much amount of run they have put on power play. But they will also say that okay, sometimes they will say partnership between partnership between like these kind of things, where you have not one thing to do, you have to do a multiple things, you have to calculate multiple sums, multiple query sums, then we use this kind of technique, that is prefix sum approach. Okay, so this is one thing. We'll create the array and we'll check, okay, like if we have to calculate between 1 and 3, what we'll be doing, we'll take the third index, that is 11, and minus the first, and that is 0th index, that will be 1. So the total sum between 1 and 3 is 10, that is 5 2 7 3 10. So this is how we were able to calculate prefix sum technique. Okay, so you can use this kind of question in online queries question. Okay, and that too if they are specifically asking sum or like something like that. So that is the place where you will be able to use this. Moving on forward, is this prefix sum approach, are you able to recall prefix sum approach, guys? Are you able to recall prefix sum? Let me know in the chat quickly, so that I can move to our second technique known as difference array technique. Let me know if you are able to recall prefix sum approach, or anyone is having some kind of doubt in it. Yes, okay, come on guys, quickly respond to me so that I am able to get it, like whosoever is there in the chat. The attendance today is very low. No problem. And you might be getting some kind of background noise. That is just because of just 1 second, guys. Are you not able to get me quickly? Just 1 second, boys. Okay, am I audible now? Hello, am I audible, guys? Noisy audio, got it. Right now it is also noisy audio, guys. Okay, am I audible now? Is my voice loud, clear, sharp, clean? Hello, am I audible, guys? I hope I am. Yeah, I know that there will be some kind of noise today for the day, as we are having Bappa's Visarjan today in Pune. So most of you guys are aware of it. No need to explain. Guys, let me know if it is better or clearer to you. Okay, okay. I'm sorry if for any disturbance, guys. Okay, so we'll move forward for the difference array technique. That what was the difference array technique, guys? So same thing, just assume what I am trying to say. Suppose if you are given an array, okay, cool, calm, but they say that they say that, I'll tell you, I'll write the indexes first. 0, 1, 2, 3, 4, 5, 6 and 7. So they question says, if suppose you have to do a certain thing from index here to here, you have to do something. That thing can be anything. From a given interval, you have to do something. Again they will say, do this, do other thing in this given interval. They will say, do the other thing in this interval. They will say, do this thing in this interval. So over here we used to have a difference array technique. How I'll tell you. So if suppose you remember the carpooling question, or one more question I have added in the our class sheet, and that class sheet goes like, that question is corporate flight booking question. So basically they will just say that, suppose this index as the marked stops of a bus, and a bus is going from 0th index to 0th stops to 7th stop. So question is saying this bus is having the maximum capacity of 8 persons at a time, okay, and the question is saying from index from at the first stop 5 people will get into the bus, at the second stop 2 people get in the bus, at the third stop 6 people come out of the bus, okay. So something like this, or they might say one more thing, like in this manner they can give the input, or they can say, so in between 1 to 3rd stops there are 5 people, okay, or it is having 5 Newton of force, okay. Then if you can imagine from 2 to 6 indexes, we are having 10 Newton of force, okay. Then we can say that 10 Newton of force is added by this, okay, and then we can say in between 4 to 5 we are having 6 Newton of force. We are not having, we are adding 6 Newton of force in between this interval, this interval, this interval. So at the end of the day, tell me what will be the force at all the indexes. Force at all the indexes, or like number of people over here in this case, like something like this only in this case too. Number of people at every stop, or they can also ask that is it possible to accommodate those people. So we need to check that, okay, if that maximum capacity is reaching or not. So what we can do in this case? So coming back to question, so 1 2 3, so what we can do basically, I will just copy paste this. Actually guys, the type of song which is getting played in the background, my body is just dancing. Somehow I am teaching, I don't know, it's like one of the best song you might be getting in the mic. Okay, so the question is saying in between 1 2 3 we are having this 5 Newton of force. So what we can do over here, we can add 5 Newton over here. They want from 1 to 3, so we will do a subtraction of 5 Newton over here. Okay, they are saying from 2 to 6 they are adding 10 Newton of force. So at index second we can add 10, and 6 they are adding, so we will subtract minus 10 over here. To up to 6 they can, so if you closely observe, up to 6, so if you closely observe, so this was this index, and from here to here we can have this 10, right? Okay, I will prove that how this concept works. And the other part was 4 to 5 we are having 6 Newton of force, 4 to 5 again. So what we can do is we can add 4 over here, so we'll add plus 4 over here, which gives you 1. Okay, and to 4 to 5, so we'll do minus 6 at 5th, no, not 5th, that is we'll do minus 6. So no, sorry, so just 1 second guys, just 1 second guys. So this was 5 Newton, this was 10 Newton, this is saying 6 Newton from index 4 to 5. So at 4th index we will be adding plus 6, so 5 minus 5 plus 6 is equals to 1, so this will give you 1 over here. And at what, at 5th index, not after 5, we can subtract minus 6. Okay, so if we do a prefix array of this, what we will have guys, tell me. 0 5 15 and plus 1 16. Oh, shall I write that in black so that is more clearer and visible to you? Yes, 0 5 15 16 10 0. So what they said that at index, now observe carefully, at index 1 to 3 they are having 5 Newton of force. So at 1 it is having 5, and at third till this point of time they are having 5 Newton of force. Okay, so you see from here to here we are having 5 Newton of force. This 15 becomes so why this is 15, because we are adding from index second to 6 we are adding 10 Newton of force. So here it is also 10, here it is also 10, here. Now they are saying that over here we need to have 6 Newton of force. So that is why like from here to here 5. So if you carefully observe, from here to here they are saying 5 Newton of force now. Okay, and here they have added 6. You can carefully observe the effect of 5 is nullified over here because of this minus 5, right? The effect of 6 is coming into picture now, this 6. So that is why, so not this 6, not up to here, up to here. So this technique was named as difference array technique. We solve the carpooling question that okay, how many persons can how many person can sit into a car, that what is the maximum capacity of car, and like then what amount of force we can have, and something like this. So are you able to recall this particular technique, when to use, where to use? Like if they are saying from index this to this, 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 we have to do this. From index this to this, again we are doing some more on top of that. From index this to this, we are doing something else. So if we are doing like from indexes, then we can use this difference array technique. Are you guys clear with difference array technique? Where to use, how to use, when to use? Are you guys clear? Let me know guys quickly. We have like 12 techniques to cover before we go ahead. Come on, so like 4 guys are watching, let me know. Like whosoever are clear, let me know clearly, or else I'll reiterate. Guys, quicker. Are you able to recall these techniques? Clear? Okay. 2 clear guys, 2 more clear to go. Okay, 3 clear guys, 1 more clear to go. Who else is there? Okay, so whosoever is watching are clear. We can move to next part. What is the next technique? Guys, the next technique is subarrays. So we'll take subarrays. I will take contribution technique first. Okay, so I am marking contribution as done, and I am going to contribution technique. So here comes contribution technique. Okay, tell me who all remembers contribution technique and what it is. Okay guys, tell me a quick if you are not clear with this what we say difference array technique, go and watch the videos again guys. I am not gonna explain again. Guys, come on, a quick formula for contribution technique. Nobody remembers? Okay, no problem, I'll explain. So contribution technique states that in how many sub-arrays the required index will come. And that technique, like suppose if I ask in how many sub arrays this index 2 will come, in how many subarrays? How many subarrays? My question is how many subarrays this index 2 will come? How are we gonna solve this question? Okay, great. I'll quickly go and will be and will I'll quickly go and I'll explain. Okay, so we remember this formula called as I plus 1 multiplied by n minus 1. You remember this formula? This many time this will come. You remember this formula or not, guys? So maybe I can rederive it to explain you that how this is going. Okay. So suppose how many subarrays? So a subarray which starts from 0, or a subarray which starts from 1, or a subarray which starts from 2. So from 0 we can go from here till here. I'll quickly draw the line. We can go from here to here, then again we can go from here to here, here to here, है ना? And like after this we can go here to here, here to here, here to here, here to here, and here to here. You remember like you remember what we used to do? So if you don't remember the derivation of the same, I have explained in depth of that how this derivation comes into picture. That for index second there are 3 terms, right? We can I'll tell you how many subarrays, like how this like if you see that how many times the index 2 is coming, maybe I can derive for you. Let's write the type of subarrays. Like I'll write. Okay, subarrays. What I am saying is I plus 1 is 2 plus 1 into n minus 1 is 6 minus 1, that is 5. 3 into 5, that is 15 subarrays. This index 3 will come, this index 2 will come 15 times. In the 15 subarrays this index 2 will come. So let's write all the unique subarrays wherever it is coming. So let's try to write, or maybe what I can do is for our okay, for 15 it will be tougher. Can we do it? Can we derive it for like small one? That will be like okay, let's derive it for smaller one, guys. It will take a lot of time for me to derive for 15. I'll quickly write it for some shorter length and subsequently it will follow. So over here I plus 2, 2 plus 1 multiplied by the length of the array is 4 minus 1, that is 3. So 3 into 3, total 9 subarrays this index 2 will come. Let's write all the 9 subarrays, guys. Okay, I'll quickly write all the subarrays. So first subarray, wherever index 2 is coming, so that will be 0, okay, 1, 2 and 3, the complete one. Okay, the second goes like 0, 1, 2. Is that fine? The third goes like 1, 2, 3. The fourth goes like 2, 3. Fifth goes like 2 itself. 2, 1, 2, 3, 2, 3. Okay, so these are like the type of indexes which we have counted till this point of time. So these all are indexes. Okay, now we will go to sixth. So which case I am missing, guys? Which case I am missing, guys? In the 9 subarrays it will come, right? I am able to get 5 only. Am I doing something wrong, guys? No. So I'm missing a few cases. Let me know which case it is. I am also trying to think. 1 to 2. Okay. So I'll start from 1. Okay, over here I'm missing 1 to 2. I'm doing for 1 to 2. This is the another case. One, that is that one we consider. Okay, 1 to 2, 1 to 3, 2 to 2, 2 to 3. Like it's will it should be 6 only? Am I doing something wrong? The length of array is 4 minus 1 3. Okay, let me check, boys. Will it be, it is n minus 1 minus I plus 1. So that was like this was already considered as n minus 1 minus I plus 1 है ना, because we are considering from this length ना. So n minus 1 minus I plus 1 was I what was that, I minus 1 na. Up to here this point was considered, so this will be n minus 1 minus I plus 1 minus 1 minus 1 cancel n minus I, right? The formula same, n minus 1 not, sorry, my bad guys, my bad, this is n minus I, and over here this is n minus I will be 2 only, and if it is 2 this will give you 2 and this will give you 6. So nobody opposed me. Great concept, guys. Good job boys, good job. Hey, how Samkit you will be able to have index 2? We are calculating it for index 2, right? How will you be able to have index 2 in 0,1 interval, Samkit? Tell me. This is n minus I. So you guys are able to recollect this? Are you guys able with that? How many sub array this index will come? This will come for I plus 1 into n minus I times. If you are not able to recollect this, no problem, go and watch the videos. Go and watch the videos that too of contribution technique. That will be very much clear to you guys. That which will be very much clear to you guys. Okay. Okay. So let's begin. So is this contribution technique, guys, clear to you? Okay, Samkit, got it. Let me know if the contribution technique is clear to you. Like how many sub arrays this index will come. Come on guys, give me a quick thumbs up. Yes, no, whatever it is. Come on, quickly. I have raised one poll. I'm just using YouTube Studio for the day because I am not able to use it on daily basis, as this is as I need to take care, like I need to do code on the Chrome, so I'm not doing any code today. Okay, so whosoever is voting, it is 2 votes for, they are clear. Let me know, guys. Come on, quickly vote up. so that I can move to next technique. ए भाई वोट करो यार, जल्दी जल्दी बताओ. I don't feel energy in you guys. Come on guys, quickly. Only 2 votes are there. Let me vote too. Guys, okay, I got the 5 votes. Great boys, great. Okay, now we'll be moving forward to sub-arrays, sliding windows, fixed size sliding windows. Up to here I am marking and I will be teaching you. So there was no concepts in sub-arrays guys. If I just don't remember the concepts of sub-arrays now. What was sub-arrays? 4 topic. Sub-arrays were nothing but part of arrays, continuous part of arrays. Sorry boys, continuous part of arrays. Okay, that's it from sub-array side. Now we go with other technique called sliding window. That is most important. So tell me who didn't got sub-arrays? Are you clear with sub-array guys? Are you clear with sub-arrays boys? Boys, are you clear with sub-arrays? Do you want me to help you that what sub-array was? That is it for sub-arrays. Nothing else. We'll move to sliding window. So in sliding window, and that too of fixed size sliding window, I am taking fixed size first. So in fixed size sliding window, what were we given guys? Okay, so the main gist of fixed size sliding window is that what? So they will be asking maximum sum, minimum sum, minimum product or maximum product, like these kind of things. Maximum sum, window, minimum sum, maximum product, minimum product, like something like that in the given range, in the given size, in the size of window given, the size of window, and that can be mostly represented with k. Suppose k is 3, so they will ask, here is the array. The array says 2 minus 1 5, 6 minus 6 2 minus 2 minus 7 8 9 minus 2 11. So they will say to find out the maximum, to find out, this will be the array given, they will ask to find out the maximum sum of a sub array of a size 3. So like this, can this be taken? No. Can this be taken? Yes. So can this be taken? What will be the sum? So the sum will be 5 minus 1 4 plus 2 6 in this. And once we move from here to here, what will happen? Okay, let's check. Let's visualize this. So sum over here will be, guys, sum is, what is sum now? Sum is 5 minus 1 4 plus 2 6. Okay. So if we move from here to here, what will happen? We will add plus 6 and we will subtract 2. We will add plus 6, we will be adding this and we will be subtracting this. So how this, what will be this sum? This sum will be 12 minus 2, that is 10. So over here maximum sum till this point of time is 10. Now again if we move from here, we'll be adding minus 6, that was 10, we'll be adding minus 6 and subtracting 1, that will be 10 minus 6, 4 minus 1, that is 5. So is it greater than maximum? No, it is not greater than. So again if you will move from here to here, so 5 plus 2 will be doing 5 plus 2, that will be 7, and we will be subtracting 2 over here, that is subtracting 5 over here, that is again give you 2. So is it greater than maximum sum? Ultimately you will come, while traversing you will come to know that, while traversing you will come to know that, while traversing you will come to know that this is the maximum subarray, maximum sum subarray. So this is the concept of fixed size sliding window. Are you guys clear with fixed size sliding window, guys? Come on, let me know. Quickly boys, quickly. Something like this will be there. They will be asking of a fixed size. Clear boys? Come on, let me know. Come on boys, quickly. Okay. Okay. Like come on guys, quickly. 9:58, only 2% voted for yes. I'm waiting for like 3 more yeses to move ahead. Then I'll teach variable size sliding window. 2 more yeses guys. Come on. Quicker. Why don't they respond here? I don't know. Hey, let me know that if you are clear or not. That's the end of the thing. Like if I'm teaching, what I'm asking to just make sure that you respond that okay, are we clear, shall we move ahead, or just like professors in college, I can do the same. I can just write whatever I know, whether you get it or not. I'm just asking and you yourself are not responding. Just make it a habit that you respond as soon as you listen, that if I'm asking something, respond as soon as you can. Okay, so that don't know, still somebody is there in the class, like after this much too, somebody is there in the class who is not responding. Then I don't know who he or she is. That really demotivates guys. Going further, I'll stop asking that okay, whether you got it or not, because this kind of trend you are not liking it and you guys are not responding it promptly, and this takes my energy and this gives me some kind of irritation too. Like sitting over here, I'm teaching you, I'm giving my time, and you guys at least you are not that much prompt to respond. Even nobody can do anything in it. Don't know who is there. Like we are a group of 5 guys now, and that too we all know each other, and only after this much of speaking and talking, the 5th guy didn't responded. I don't know who he is or she is. Okay. Okay, let me get a quick break, guys. Like, okay, Mahima was there. Great, Mahima, great. Great, Mahima. Well done. Good job to irritate me. Okay, so what is happening in variable size sliding window? So in variable size sliding window, they will ask maximum length in order to get sum as 5. So you see how the question revolved. Over here they are asking maximum sum in the length 3, okay, and over here they are asking maximum length in order to get a sum as 5. So in this question you will get sum 5 for like one length, then there will be a array where you will be getting. So I'll give you a good example. Wait, I'll give you a good example, very good example. So the first length, so the first sub array having sum 5 is 1 only, okay. The second sub array can be 2 comma 3. This can be the second sub array where the length is 2, and like over here if you carefully observe, this can be one more sub array, guys. Over here this can be one more sub array with the sub array that is giving you the sum 5 and having the length 3. Over here there is one more sub array with the length with the sum 5 but length has 5. They can also give you one thing, and this can also be one sub array where the sum is 5 and length is 9. So this is the perfect example for variable size sliding window. So you will be having, in this type of question, you will be having 2 pointers. One will be start pointer and the other will be end pointer. Initially they will start from initial index u only. I will write it. You will, in this type of question, have a given index like start and end. You will keep on moving end until you reach sum 5. You will keep on moving the end until you reach the sum 5. As soon as sum is greater than 5, what you will be doing? You will do start minus minus. You will keep the trimming. You will keep trimming. You will keep trimming until you reach the sum either equals to 5 or less than 5. Okay. If sum is, I'll tell you. I'll write the conditions over here so that it will more clarify to you. Okay. If sum is less than 5, you will do int plus plus. Okay. Yes or no? If sum is greater than 5, you will do start plus plus. If sum is equal to 5, you will check your max len and you will do some kind of certain condition. So in this type of questions, you will have to make sure whatever condition the question is giving between start to end, between the length start to end, you have to fulfill that condition in between start to end pointer. You have to fulfill those conditions in between start to end pointer, and over there that will give you this kind of things, like this kind of max lane, or that if you are fulfilling the condition, you then you need to check like if it is maximum sum, maximum product, or like they will say, like you remember minimum window substring question, that okay, they will say no characters should be repeating, maximum length of the sub array where no character is repeating. So there you need to take the hash map, and then you need to do some certain calculations based on the frequency map. You remember frequency map, guys? You remember frequency map, guys? Yes. So like you don't need to duplicate the like letters, characters. You just can have only one character, or like then there was that question, maximum fruit into basket, guys. You remember that you can have only two type of fruits into your basket, and once moving forward you can have only two type of fruits. So that kind of stuffs, guys, can be solved with maximum window substring, or like this sliding window pattern. So are you guys able to recall sliding window pattern? Okay, still like 3 more % to go, like 2 more % to respond, guys. 2 more % to respond for sliding window, variable size sliding window, guys. Whosoever is watching, do some mercy on me and guys respond. Like 5 of you are watching. Yes, yes. Okay, good. Thank you, guys. Thank you for responding. Somehow I got irritated with this. I'll make sure that from class 2D matrix onward I won't ask you any questions. I'll teach whatever I know and I'll go. So I'll take carry forward technique. So what that technique justifies states that you need to carry a vital information throughout the array. As for example, you are given an array of characters A, B, G, G, C, A, G, A, G. So you are given the characters and they are asking that give them that how many A and G's are possible, unique A and G's are possible. How many unique A and G's are possible over here. So unique A and G's possible are, I'll tell you, at index 0, 2, at index 0, 3, at index 0, 6, at index 0, 8. Then at index 5 comma 6, at index 5 comma 8, then again at index 7 comma 8. So where index of I, that index of A, wherever A is coming should be less than wherever G is coming. So over here if you see 7 is always less than 8, okay, 5 is always less than 6, 5 is always less than 8, 0 is always less than 8, 0 is less than 6. So these kind of approaches. So over here you just need to do a maintain a counter that will count A. So we'll see count A. So over here we have 1A, so we'll mark our counter as 1. If we move forward, is it G? No. Is it G? Yes, it is G. So as soon as we encounter G, we'll add sum equals to sum plus A, that is counter of A. Sum equals to sum plus counter of A. That will be, sum was 0 initially and counter of A is 1. So that the sum will be 1 at index this. As soon as you move over here, again there is no change in counter, but there is change in sum because we have one more G over here. You move, this is C, no problem. You move over here, yes, we have encountered A, so this counter will be going to 2. Okay. As soon as you encounter G over here, you will add in the sum you will add the count of A, that will be 2, this will be as 4. So at this point of time you have 4 pair of A and G possible. As soon as you move over here, you will increase the counter of A as 3 at index 7, and as soon as you move on the index number 8, you can increase 4 with the counter of A, that is 3, 7. Let's count if the 7 is the right answer or not. 1, 2, 3, 4, 5, 6, 7. So we have carried the vital source of information, vital source of info, that is A, count of A in our case. So there was one more question, that is known as leaders in array. So leaders is array can be termed as so suppose I'll tell you, this question goes like, I'll write the same example because my mind is frustrated now. So leaders in array says that how we can find leader. How we can find leader, and leaders if that number is greater than all the numbers in it right, that number which is greater than all the numbers in its right, then that number is counted as leader. So initially leader can be 0, but if you see, observe carefully, is this number greater than all the numbers in the right? No. Is this number greater than all the numbers in the right? Yes. So this was 1 because this was greater than all the numbers in right, then this is 2, this 7th is 2, that is 15, 7 are the leaders till yet. Is 2 greater than all the numbers? No. Is 5 greater than all the numbers? Yes. Is 4 greater than all the numbers? Yes. Is 2 greater than all the numbers in the right? No. Is 3 greater than all the numbers? Yes. So basically there is no one in the right, so that is by default a leader. Now, so for that, every time you will go and check, okay, for this what will be the brute force for you guys. So you can go, you will take this number and you will check all the numbers which are coming in the right are greater than the coming number or not, yes or no. So this is going to take order of n square time. But if you carefully observe, if we save a max variable and iterate it from right, so up to here max is 3, count is 1. If this is less than max, this is not the leader. Again if we go and we'll check how many times we are updating max. So we are updating max over here, so leader will increase. We are again updating max over here, leader will increase. We are again updating max over here, leader will increase. We are again updating max over here, leader will increase. So if we calculate max from right, we can check that okay, and we can see that how many times we are updating, then we are able to calculate leaders in the array. So over here we are carrying forward the max value and checking that how many times it is, like whatever thing you can check how many times it is updated. So carry forward is done, guys. I'll move to 2 pointers. So 2 pointers basically are used in 7th type of pattern, that is 2 pointer. So basically try to use where the array is sorted. There are different techniques in 2 pointers. Most of them will be learning in linked list topic, guys, but 2 pointers can be used in wherever the array is sorted, guys. Okay, like if you carefully observe in this 1 2 3 4 5 6, in this question they are asking sum as 7. So they are asking find the pairs which gives you the sum 7. Find two numbers which gives you the sum 7. What we can do, we can keep a start pointer, we can keep a end pointer. We'll see if start plus end is equals to 7 or not. So 1 plus 9 is equals to not equals to 7. So this is giving us sum 10, but we need 7. So in order to get 7 and we are at sum 10 and that array is sorted, we need to decrease our end pointer, we need to shrink our end pointer, not the start pointer, because if we shrink the start pointer, the sum will keep on increasing. I'm sorry, if we decrease the end pointer, the sum will shrink. The sum, if we decrease the end pointer, the sum will go down. So subsequently we can have start plus plus and end minus minus based on some certain conditions, and that is how we'll be having this 2 pointer approach. 2 pointers are basically meant to solve good and huge amount of problems, like maybe you can refer the videos for further explanation. Then there was one more technique, that is mod technique. I'll take a break of 2 minutes, guys. Hello, all, I'm back. Let's wait for 10:25 until we begin the class. Okay, boys, I'm back, and like whosoever is there, will begin sharp at 20:25, and it's 10:25. We'll begin go back home technique. So in go back home technique, boys, what we used to do was uh, to send the numbers in their home. So we remember a question called as first missing positive integer. Over there, guys, you remember one concept that the array can be given in such a form that by so they will give you, they won't give you the range. In basically these kind of questions you need to observe a pattern. Okay, the pattern will be the number in this particular question, the number in this particular question will be in some range, and that range can be n to n plus 6, or like over here if you see how many numbers are there, 0, 1, 2, 3, 4 and 5. So if you carefully observe, so they are saying that they won't say this something like this. You have to observe this with your own observation. You see the your own observation over here, guys. N comma n plus 6 is there. It starts from 20, it goes to 26, and they will, and the question, like you can directly use this kind of technique. So all the techniques which I am teaching you can't directly be used. Sometimes those techniques will be used in the intermediate question. Like if you have like 3 parts in a question, part 1, part 2, part 3, so you will have input as the normal and output as, like I'll explain that how to think of a question. So suppose you are given with a question. I'll give you a good example, guys. Suppose you are given with the question, question is having some kind of input. Okay, guys, so we will be having 3 phases, that is phase 1, then we'll have phase 2. This is not only the question, guys, this is a thing which we do in our development too. Before writing a method, like today only I was doing some kind of development in my code. Over there I use this technique only. First be clear that what you want to do. Okay, so this phase will take the question's input and give you temporary output. Temp output 1, you will be using this temp output 1 as the input for the phase 2. Okay, and then you will do some certain sort of calculation, and you your phase 2 will give you temp output 2, and you will use temp output 2 again over here in phase 3, and you will find the output, of the question. So this is how we think of a hard problem. So over here, till this point of time in your life, you might have solved easier problems, right? In order to solve easier problems, you don't need to, your brain thinks very quickly and you are able to solve it. Until this point of time, whatever I have taught, that type of only questions I have asked you to solve. So for you, that was very easy. So think somewhat in this direction. Every time if you get a new question, think somewhat in this direction, that okay, I'll be given an array, that array will be something like this only. Okay, now the question is saying that, just I'm telling you that like, moreover, you know that if we are gonna use go back home technique over here, you will be pretty much easier, you will be very easy to get the things, like you will think in that direction only, but I'm telling you in a generic approach. So the question will say, find the missing number in the sequence, find the square of missing number in the sequence. So what you will be doing? Over here we can break this problem into two problems. The first problem, we need to find the missing number, and second is square of that number, right? So these two things are different things. So over here, to find the missing number, first you need to find, okay, how I can find the missing number. Like, okay, I have written an example so that it is very much observant that we are gonna find the missing number, but once you see the question, you might not be able to catch it, that okay, it's the missing number question, or it's the like go back home techniques is getting used. I'll like, whenever I'll be setting my question, like for the test, for the upcoming test on Saturday, I will make sure that I set one question based on this, pakka, because I have used this technique n number of times in n number of different problems, wherever you can't find that missing number technique is getting used. So what you can do, so you can send actually over here, you can send 20 over here, 22, that 26 will come over here, 22 will go over here, 23 will go over here, 24 and 25 और समथिंग लाइक यहाँ पे 27 भी हो सकता है, 26 कुछ भी हो सकता है. So you sorted, you send everyone to their home. 26 is, since it is not having any home, so it came over here. You will come and check, every time you will subtract 20 from everyone. You are not changing, modifying the array, you are just subtracting on a local basis, and you are checking that okay, if this is not the number, then it's the missing number for you, and this is the missing number, then you will find the square and you will give it. So some sort of this will be used to find the missing number technique, guys. So mark my word, these techniques help a lot. Don't ever jump directly from here to here, go by this path, come to this, come to this, come to this, and then come to this. This will every time help for a hard question and for medium questions too. This is my observation till this point of time in my life. You guys are great and you guys have good knowledge to understand this. Like else, I'll wrap up the class in next 5 minutes. Maybe I will carry on this class on Saturday. From here, this is done. I will take a quick class on Saturday where I'll be explaining 8th, 10th, 11th, 12th and 13th in short detail. That class will be of half an hour. And that is it from my side, guys, today. Hope you like the class. We'll have the test on Sunday 10:30 a.m. sharp. Everyone needs to prepare 2 questions. Maybe I'll write this all somewhere unofficially. Till then, bye bye. Good night.